chemical energy as heat. As heat. Okay. Then we have heat energy. Okay. What is heat energy? This is the energy contained by the molecules and atoms at microscopic level. Means if you add the kinetic energy of every molecule, every small molecule in a gas, okay, gas or solid, even solid or liquid, whatever. So if you add the kinetic energy can have various parts due to vibration, due to rotation, due to translation. So if you add all of them, we get the heat energy. So what is heat energy? It is energy of all the molecules and atoms, all the kinetic energy of molecules and atoms at microscopic level. Okay, so this is the heat energy. Okay, so this is summation of all the kinetic energy at microscopic level. So if you sum all of them, that appears as heat to us. Okay, so at large scale, we are not able to see the small vibration and rotation of small molecules, but whatever heat we experience, that is due to the microscopic motion of all the particles. Okay, so this is the heat energy. Now one thing, now next one is the nuclear energy. So this is what? This is the energy released when a nuclear reaction takes place. So this is energy released when a nuclear reaction takes place. Nuclear reaction takes place. Okay, so what is this? Example we can take. The example is the energy coming from sun. So that is also coming due to nuclear reaction inside the sun. So energy production in sun is due to this one. So energy production in sun okay, and in nuclear reactors or nuclear bomb. Okay. So one thing we should see here, although in this chapter we have studied the conservation of mechanical energy only, the total energy is conserved. Means all the energy, if energy is just converted in a process, suppose something is burning, then what happens, that chemical energy is lost and heat energy is produced. So energy is neither destroyed nor created, but they are converted from one form to other form. So energy is neither destroyed nor created. Energy is neither destroyed nor created, but converted from one form to other form. Converted from one form to other form. Okay, so for example, but we have one exception, so that we will write at the end. So for example, in chemical cells, the chemical energy is converted to electrical energy. In case of suppose two objects are collided, two objects is colliding, then the mechanical energy of collision is converted into maybe converted into sound and light energy. Okay, so in this way we have energy converting from one form to other form. But there is one example, the nuclear energy. In nuclear energy is created from mass. So that's why we always say mass is equivalent to energy. Okay, mass is equivalent to energy, and that's why we study mass energy equivalence. So if a mass, the only energy is not conserved, but we have mass energy combined conserved. Okay, so what we say is only energy is not conserved, but we say that energy along with mass, energy along with mass is conserved. So what is this meaning? Along with mass. So that is called mass energy equivalence. Okay. So mass plus equivalent energy is conserved. Okay. In nuclear reactor, that is seen. So in nuclear reactor, some mass is destroyed and that mass appears as energy. So what is the relation between mass and energy? Equivalent energy is conserved. So this is M equal to, E equal to mc square. E equal to mc square. Okay. So if you have 1 gram mass destroyed, corresponding to that, you will have some energy created. Okay. So formula is given by this. So example we can take, if 1 kg mass is destroyed, 1 kg mass destroyed and converted into energy, 1 kg mass is destroyed and converted into energy. So this mass is completely destroyed. This is not something like burning of a paper. In burning of paper, mass is not destroyed, but the solid part is converted into gaseous part. Okay, so that is not destruction of mass. But here the mass is completely lost. In nuclear reactions, this happens. So if 1 kg mass is destroyed and converted into energy, then energy is equal to mc square. So we can write how many joules it will be. It will be equal to 1 kg into c square. So 3 into 10 to the power 8 square joule. So we are getting 9 into 10 to the power 16 joule energy. So by destruction of 1 kg mass, we have a huge amount of energy created. This is a very large amount of energy. Okay, so that's why nuclear bomb is very powerful. Even a small amount of mass is destroyed in the process of nuclear explosion. A huge amount of energy